Hi, my name is Ryan and welcome to the Healthy Home Movement. If you're designing a home or thinking about designing a home, you're in the right place. Today I'm doing a series of videos called the Passivhaus. I'm just going to quickly go through the standards and what they actually mean. I appreciate you might have an overview of one or two, but I'm just going to quickly run through all of them. So the specific heat demand, that is how much your space heating needs to produce throughout the annual period, which is significantly lower than a typical building. Same with the cooling. Again, this is limiting mechanical cooling. A lot of our UK homes do not have mechanical cooling, so this requirement is a little bit not anything to worry about. Secondly, the space heating demand is at 10 watts per meter squared. To put this in perspective, a typical home we use will require 50 to 60 watts per meter squared. So we have brought this limit all the way down to 10, which is great. The key one is 120, which is your overall specific primary energy demand for your building, and that's per year. So what a lot of people talk about is the air permeability in a passive house. To put it in perspective, if you added all the holes up, would add up to roughly about the size of a 50p piece. In comparison, a new build home would add up to an A4 piece of paper, effectively the same size as an iPad. So the difference is quite substantial. Same with walls, glazing, installed glazing, and doors. The U values on them are significantly lower. To put in perspective, a glazing unit is 0.8 watts per meter squared, which is the U value. Just if you're not aware of what U value is, a U value is effectively how much energy a material would emit, and depending on the difference in temperature. So so 0.8 would emit 0.8 watts per meter squared of the wall area. So and then per Kelvin, which is a standard unit of temperature. But you're probably more used to Celsius. It's the same thing in this sort of instance because you're using a difference. So the lower your glazing unit U value is, the better its efficiency. So for example, 0.8 is what we require for glazing. A typical very high performance glazing in the UK is considered around about 1.1. So even you can see that 0.8 is very hard to get. A normal glazing unit would be 1.4 to 1.7 is what would be normally expected. We've talked about infiltration. Thermal bridging, that is in each corner of a building, is called a thermal bridge because that is where your weak points are. The more corners you have, the more energy your building will release. It's much more efficient to have one flat surface rather than multiple cornered surfaces. That would need to be calculated with your architect. In MVHR units, its efficiency is 0.75. So what this means is that the heat recovery is at 0.75. So you're extracting air from a space and expelling it outside. Before expelling it outside, you recuperate some of that energy, which is 75% of it, by putting the fresh air coming in over the heat exchanger into the space. What's one clear thing to remember is that you're not physically mixing the air, you're just transferring energy from one to the other using a heat exchanger, an air heat exchanger. Ventilation electric limit is at 0.45. That is effectively the specific fan power. We use more of a standard unit of specific fan power in this country, which they both mean the same thing. It's the amount of energy it requires to move your air around your building. So the higher your specific fan power or higher your electric limit, the more energy you're using. The reason why this is important is that some MVHR units can be undersized for the space, which will then require a lot more energy than if the unit was appropriately sized. All appliances have to be A rated. Lighting should all be high efficiency fittings. And on-site renewables, what we discussed before and previous in the series, is that there is no real requirement for renewables, and this is because the standards are looking at energy consumption, energy reduction, not carbon footprint. by reducing your energy reduction, it's reducing your carbon footprint, but it doesn't look at completely eradicating it or providing any additional energy generation on site. Thank you for taking the time to watch this video. I hope you found it useful. There'll be more in the series, so please click subscribe. If you have a question, please leave a comment below, or feel free to give me a call or an email. If you'd like to join the Healthy Home Movement or would like to know more about the Healthy Home Movement, please visit us on our website, which is a free community that shares stories and ideas. Again, please remember, if you're going to build a home, build a healthy home. Thank you.